Welcome to the last section of complex numbers and imaginary numbers. In this final part, we're going to talk about the powers of I. So we already discussed that I is equivalent to the square root of -1. So if we square the square root of -1, we get -1. And we talked about this earlier. But we did not talk about higher powers of I. So what happens if we have I cubed? Well, that essentially means we're going to do I times I squared. When you have like bases, you add the exponents. So 1 plus 2 gives us I cubed. Okay, but what does that mean in terms of a value? Well, we know I is the square root of -1, and we know I squared is -1. So this becomes negative square root of -1, or negative I. So both these are ways that we can express I cubed. So it's negative I. Now, I to the fourth is a special one. That's why there's a star next to it. And this can be expressed as I squared times I squared. Add the exponents, you get I to the fourth. Now, why is that special? Well, because we know I squared is -1. So we have -1 times itself, -1, and we get +1. Negative times negative equals a positive. So this one is special because it makes it much easier to do some of these higher powers of I. And we're going to demonstrate in just a second. So as we move to the I to the fifth power, what does that equal to? Well, we could break it down into components of I to the fourth times I to the first. Add the exponents, 4 plus 1 equals 5. But what does that mean? Well, we know I to the fourth is +1, and we multiply it by square root of -1, so we just get square root of -1, or I. So I to the fifth is equivalent to I. Now, why do I have written here I to the fourth as the first component for each one of these? Well, because it's the easiest to reconcile. We know I to the fourth is 1, so if we can break down any higher power of I using I to the fourth, it makes it much, much easier to do these problems. So now we have I to the sixth. So I to the sixth is equal to I to the fourth times I squared. That's the same thing as, +1 times -1. Or just -1. So we get the same answer for I to the sixth as we get for I squared. I to the seventh, likewise, I cubed. So that's 1 times the square root of -1, which is just the the negative square root of -1. So we just get the negative square root of -1, or negative I, for our answer here. So I to the seventh is the same as I cubed. And then finally, we have I to the eighth is the same thing as I to the fourth times I to the fourth. Add exponents, 4 plus 4, 8. That's 1 times 1, or 1. So we get the same thing there. Now, you're going to see that this is going to repeat, this same 4-sequence pattern is going to repeat over and over and over and over for all the powers of I. So I to the ninth is going to give you square root of -1. I to the 10th is going to give you -1, and so on and so forth. Okay, so that's the pattern there, and it just helps with some of these higher powers to use I to the fourth as your basis. So let's emphasize that. Maybe I'll highlight it. That'll make it look better. So I to the fourth is going to be our basis for all these problems. And I hope you get the idea. Shade, shade, shade. Okay, there we go. Okay. Now, how can we use I to the fourth to express some of these ones? So we have I to the 12th is our first example. So what can we do with I to the fourth to get to I to the 12th? Well, we can manipulate it in any way we want as long as it's equivalent. So what I'm going to do here is I recognize that 4 times 3 is 12, so I'm going to raise I to the fourth to the power of 3. Why? Well, when I multiply, or raise a power to a power, I'm going to multiply exponents. So this will give me I to the 12th. Why is this useful? Well, I know I to the fourth is -1. Oh, sorry, +1. That was the whole point. It's an easier one. And then we raise that to the third power, and we just get 1. So I to the 12th power is equal to 1. And that's why using I to the fourth is useful in this situation. Now, for the second problem, we have I to the 39th power. This one's a little more tricky because we need to get to a number that's not a factor of 4. 12 was a factor of 4, so it made it easy. 39 is not. So we need to think of the number that's closest to 39 that is a factor of 4 without going over. And that number is 36. So I to the fourth, and then how do we get to 36? We multiply by 9. 4 times 9 is 36. Okay, but that doesn't get us all the way. We still need 3 added on. So we have to multiply by the same base, which is I, and then we raise that to the third power. This will give us 36. 4 times 9, 36. And then we add the exponents. When we multiply of like bases, we get 39. Okay, so this is the components broken down that will give us what we need to get to 39. So we can go ahead and simplify now. So we have I to the fourth. We know that's 1. That was why we chose I to the fourth power. And then we just multiply by I cubed. And we can reference it up here, but we know that's negative I. 1 to the ninth power is just going to be 1. That's the whole point in choosing that. Times negative I. This is just going to give us negative I, or negative square root of negative 1. Moving on to I to the negative second power. This is the same thing as 1 over I squared. 1 over I squared is the same thing as 1 over negative 1, or just negative 1. So you can see with negative exponents, there's still a repeated pattern going on here. Let's do our final one of I to the negative first power. That's the same thing as 1 over I. We shouldn't have an I in the denominator, as we kind of showed in the other video, so we're going to multiply both the top and bottom by I. So we have I over I squared. Now you can see that we can simplify I squared. That becomes negative 1. I divided by negative 1 is just negative I, or negative square root of negative 1, which is equivalent to I cubed. So there's some interesting things going on. We repeat the pattern forwards and backwards. I to the 0 would give us 1. So we can see that it even continues if we go in the other way. If we go in reverse, this is I to the first. If we go I to the 0, we get the same thing as I to the fourth, which is equal to 1. Sorry, I'm writing over it. I to the negative 1, same thing as I cubed, which is negative I, and so on and so forth. So it's very interesting that the pattern repeats itself, and now you have the tools essentially using I to the fourth to break down all these components of higher powers of I. Hope you enjoyed this video, and I'll see you next time on West Explains Best.